So today we have a cool geometrical theorem. I don't know the name of this theorem, but it's very beautiful. Take a normal triangle A, B, C. Now inside this triangle inscribe 4 circles such that they are tangent to each other and also they are tangent to the sides of this triangle. Now because of this arrangement there is a beautiful relation between the radius of the circles. So if the radius of these 3 corner circles are taken as A, B and C and radius of the middle circle as R, then the relation is square root of AB plus square root of BC plus square root of CA is equals to R. So this is Anmol Mishra, and now let us see the solution. How can we prove this relation between the radius? So first of all we will start the solution by utilizing the fact that the circles are tangent to the sides of this triangle. So already one of the radius has been drawn to the tangent point in the yellow color. So as per the theorem, the angle at the point of intersection of the radius and the tangent line would be 90 degree. Therefore all these 3 angles over there and the top angle over there would be 90 degree. Okay. Now we can see that there is one more tangent point in the circles. So let me draw the radius to that points also. And again the angle over there would be 90 degree. Now let the centers of this circle be the point P, the point Q, the point R and the center of this top one be the point S. Okay. Now what I will do is I will simply draw a line segment that will join the points A and P. Okay. Now what we can observe over here is that this triangle and this triangle are congruent because of right angle, common hypotenuse, and these two sides are equal because they are the radius. So once two triangles is congruent, rest of the things between them become equal. So this and this angle become equal and let it be equals to alpha. So what we can observe over here is that 2 times alpha is the angle BAC. Okay. Now let me just remove this thing from here. And now what I will do is I will draw a line segment joining the points A and Q. Okay. Now again look carefully in this triangle that is over here and that triangle that is over there. Both these triangles are again congruent because of right angle, common hypotenuse, and these two sides are equal because it is the radius of the middle big circle. So two triangles are congruent, rest of the things between them become equal. Therefore this and this angle become equal and let it be equals to theta. So what we can see now is 2 times theta equals to angle BAC. And for the previous case we have got 2 times alpha equals to angle BAC. So comparing this both, what we get is theta equals to alpha. This means the slope of the line AP is equals to slope of the line AQ, and this simply means that the point A, P and Q are collinear. AP is not equals to AQ, their slope is equal, remember that. So this means the point A, P and Q are collinear point. This means the line that I have just drawn is straight line joining the centers of these two circles from this vertex and dividing that vertex into 2 equal angles. Okay. Now the same thing can be done on the other side. The point QRB would be in a straight line, and similarly on the top, the point C, S and Q would be in a straight line as is the center of that smaller circle. Okay. Now again note that I have told you that these two triangles are congruent, and from there we have marked theta equals to theta. But at the same spot these two angles would also be equal and let it be equals to capital A. Similarly these two triangles would be congruent, hence this angle over there would be equal and let it be equals to capital B. And similarly these two angles would be equal because these two triangles would be congruent, so let it be equals to capital C. So now what I will do is I will draw a straight line from the point P to the radius R. So we can see that the base and this line would be parallel because we have drawn a straight line. So parallel lines, we can utilize the fact that the collinear angles in a parallel lines are equal. Therefore this angle over there would also be 90 degree. So this angle by linear pair and by angle sum property this angle also. So here we have formed a rectangle. So in rectangle opposite sides are equal. So if this much length is equals to A, the distance over here, let me clear this thing. The length from here to here would be equals to A. The complete distance is equals to R. Therefore the remaining distance, so the triangle will form like this, this and this is 90 degree. This much distance would form R minus A. Okay. Now look carefully that over here, this is the tangent point between these two circles, and we know this theorem very well that if there are two circles that are tangent to each other either externally or either internally, the center of both of the circles and the tangent point would be in a straight line. Either the case is internal or either the case is external. In both the cases, the centers of the circle and the tangent point would be in a straight line. So the same thing is over here. As we have seen that the center P and the center Q are in a straight line, so it will also pass through this tangent point. Okay, so now the distance from the point P to this tangent point is A, radius of the circle. Distance from the tangent point to the point Q is radius of the bigger circle, that is R. And as it is a straight line, the complete distance would be R plus A. So in this right angle triangle, we have got the hypotenuse as R plus A, the side as R minus A. So by applying the Pythagoras theorem, we can get the base as 2 times square root of RA. And look carefully that this angle over here is capital A in this triangle. Okay, so I'm just removing all the markings from this first triangle, and now we will proceed to the other triangle, that is this one. Now the same things we will do on this circle. So let me just remove this thing so the diagram looks clear. Okay, so now I will draw a straight line from the point R to the radius of this circle, the middle circle. So this would be parallel to the base, hence corresponding angles become equal. So if this angle is 90 degree, this angle also becomes 90 degree. By linear pair this is 90, and by angle sum property that is 90. Okay, so now we have a rectangle form over here. So if this much distance is equals to B, that is the radius of the circle, so from here to here the distance is B. The complete distance from the center to here is R. Therefore the remaining distance, that is from the center to this point where the 90 degree is present. So let me just redraw that triangle outside the diagram. So here is the 90 degree. Now what is formed over there is like this way kind of structure. This much distance is B, the complete distance is equals to R. Therefore this much distance is going to be longer minus the shorter, and that is R minus B. Okay, now what we can see is that the center of this circle, the center of that circle is in a straight line. So as per this theorem, the center of this circle, the center of the bigger circle, and this tangent point would be in a straight line. Now the distance from R to the tangent point is B, radius of this circle. The distance from Q to this tangent point is radius of this bigger circle, that is R. So the complete distance from here to here, that is from Q to R, becomes R plus B. Okay, now by applying the Pythagoras theorem, we get the length of base as 2 times square root of RB. Now the same thing can be done with this top smaller circle. From here to here I will draw a straight line. This much distance will come out to be C, R minus C, R plus C. So the triangle will form like this way. The diagram is very small over there, so I'm just drawing it outside it. So the triangle will form like this way. Here's the 90 degree. This height would be R minus C, the hypotenuse would be R plus C, and by Pythagoras theorem we will get the base as 2 times square root of RC. Okay, now again make a note that the triangle formed with the circle of radius B, in that triangle one of the angle is the angle capital B, and in this triangle formed with the circle with radius C, one of the angle is capital C. Okay, so now over here we have 3 right angle triangles, and they are formed due to the pairing of the middle circle with 3 of these corner circles. Okay, now look carefully that all of these 3 triangles contain the angle capital A, capital B, and capital C. And look in this diagram, we have 2 times A, 2 times B, and 2 times C, as the triangles were congruent over there, and it is forming a complete angle. So we know this thing very well, that a complete angle is 360 degree, and as per our diagram, 360 would be equals to 2 times A plus 2 times B plus 2 times C. Okay, so by dividing both of the sides by 2, we get A plus B plus C as 180 degree. So here we have a nice relation between A plus B plus C, that is 180 degree. Okay, so till now we have got 3 right angle triangles with the angle capital A, capital B, and capital C, plus a relation that A plus B plus C is 180 degree. Okay, so now what I will do is I will forget all this thing and look for something else that is just a trigonometric identity. So what I will do is I will take 3 angles X, Y, and Z, and I will suppose that X plus Y plus Z is 90 degree. Okay, we have a situation like this way, 3 angles are there, addition of the 3 angles is 90 degrees. Now what I will do is I will shift Z on the other side, so X plus Y would be 90 minus Z. Now I will take tangent on both of the sides, therefore tangent, that is written as tan of X plus Y, would be equals to tangent of 90 minus Z. So tangent of 90 minus Z. Okay, Now this is a nice identity. Tangent of x plus y would be tangent of x plus tangent of y divided by 1 minus tangent of x tangent of y. These are very basic trigonometric identities. You should remember that. Okay. So tangent of x plus y is this thing. What about tangent of 90 minus z? So tangent of 90 minus z would be cot of z. Simple complementary angle is there. Now cot of z can be written as reciprocal of 1 upon tan of z. Okay. Now I will do the cross multiplication. So I will get tangent of x multiplied with tangent of z plus tangent of y multiplied with tangent of z is equals to 1 minus tangent of x into tangent of y. Okay. Now I will shift this negative term on the left hand side. So removing this thing from here, and as it was negative, so here it will become positive, and I will get tangent of x multiplied with tangent of y added with all the remaining terms for a situation x plus y plus z equals to 90 degree. Now you might have guessed that we are going to use the same thing over here, but there is a problem over there. We don't have any relation between angles that gives us 90 degree, but we have this thing a plus b plus c equals to 180 degree. I can simply divide both of the sides by 2, so I will get a upon 2 plus b upon 2 plus c upon 2 as equals to 90 degrees. Okay, so here we have got the relation that addition of three angles equals to 90 degree, but the angles here formed are a upon 2, b upon 2 and c upon 2. So now as we have seen that if three angles were 90 degree, we get this particular equation in terms of tangent. This means we need the value for tangent of a upon 2, tangent of b upon 2 and tangent of c upon 2. We need the tangent value for these three angles, so we can put in this equation. Okay, so what we can see that we have right angle triangles, and in that the angles are a, b and c. So no worries, we'll utilize that thing to get the value for half angle. So for that, let me take the first triangle like this way. Okay, in this triangle, this angle over here is a. Here's the 90 degree. This side with a is r minus a. The height is 2 times square root of ra, and the hypotenuse is r plus a. Okay, and let this triangle be labeled as j, k, l. Okay, now what I will do is I will extend the base of this triangle as a straight line and mark a point M over there such that the length of LM is exactly equals to the length of LJ. That is, the length of the hypotenuse equals to this line. Now I will simply draw a line segment joining the points J and M. Okay, now the length of JL is r plus a, and as we have drawn LM equals to that only, so the length of LM would also be equals to r plus a. Okay, now look carefully that over here we have this triangle, and in that this angle is a. So by linear pair, this angle over here would be 180 degree minus a. And now look carefully in this triangle, that is the triangle JLM. One of the angle is 180 minus a, and as these two sides are equal, these two angles become equal, and that would be equals to what? That would be equals to a upon 2. You can just use the angle sum property and you will get that these equal angles are ultimately a upon 2. Okay, so now look in this triangle, that is JKM. First of all, it's a right angle triangle. I am talking about this complete triangle. So it is a right angle triangle, and in that one of the angle is a upon 2. So from that perspective, the value for tangent of a upon 2 would be height, that is 2 times square root of ra upon the base. So the complete length of the base would be r minus a plus r plus a, and that would be 2 times r. Now 2 and 2 can be cancelled out, so this and this got cancelled out. Now in the numerator we have square root of ra, and in the denominator we have r. So square root of ra can be written as root r into root a. Now I will simply multiply root r in the numerator and in the denominator. So now in the numerator, square root of r into square root of r becomes complete r, and that got cancelled out with the denominator one. So we finally get the value for tangent of a upon 2. That would be square root of a upon square root of r. Okay. Now using the same technique, that taking the right angle triangle, extending the base such that it is equal to the hypotenuse, you can easily find the value for tangent of b upon 2 and tangent of c upon 2. So when the case is done with tangent of b upon 2 like this way, this length equals to this length, r plus b, so this is also r plus b. This angle forms b upon 2. So we will get the value for tangent of b upon 2 as 2 square root of rb upon 2 times r, and the same simplification that we did previously, we will get its value as square root of b upon square root of r. And similarly with the third triangle, we will extend the base such that it is equals to the hypotenuse. This length would be again r plus c. This angle forms c upon 2. So over here we will get the value for tangent of c upon 2 as equals to 2 times square root of rc upon 2 times r. In the same previous work, so we will get its value as square root of c upon square root of r. So here we have the value for tangent of c upon 2. Okay, so here we have got all the required things. Now we need to just assemble it. So remember that if addition of three angles is 90 degree, using this thing we get this equation in terms of tangent. So again we have the same thing, addition of three angles 90 degree, a upon 2, b upon 2, c upon 2. So from this we will get the same particular equation. So the equation will look like tangent of a upon 2 multiplied with tangent of b upon 2 plus tangent of a upon 2 multiplied with tangent of c upon 2 plus tangent of b upon 2 into tangent of c upon 2 equals to 1. This equation comes true when addition of three angle is 90 degree. Okay, so now we have got the values for tangent of a upon 2, b upon 2 and c upon 2. So let us replace it over here. So tangent of a upon 2 has a value root a upon root r into tangent of b upon 2 that has a value root b upon root r plus tangent of a upon 2, so root a upon root r into tangent of c upon 2 that is root c upon root r plus tangent of b upon 2 that is root b upon root r into tangent of c upon 2 that is root c upon root r, and this thing is equals to 1. Now the denominator of all this fraction would look like root r into root r, and it will form a complete single times r. Similarly in all this term, root r into root r will turn out to be single times r. So all these terms have the same common denominator, that is r, so it can be shifted on the other side, means multiplied with 1. So on that side we will have r. Okay, we got the r in the right hand side. What about the left hand side? So we can see that in the first term we have the numerator as root a into root b, so it will form complete root ab. The middle term is root a into root c, so it can be written as complete root ac, and the third one is root b into root c, so it can be written as complete root bc. So now we have the left hand side of the equation as root ab plus root bc plus root ca, and this thing is equals to r, and that is the relation that we need to prove. So this is the last video of the year 2021, and this is one of my favorite theorems. I have proved it 2 times. This is the second time. Previously when I proved it using trigonometric only, but the method was a little lengthy. You can watch that video, the link is in the description. So if you have any other method other than these two, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.